So in this video we will see how to resolve some axiom problems and some vector problem. So the first problem is that we have this equation a0 x So first we want to see if this has the 10 axioms. So if one fails, it means that it is not in the rules. So we have to set up our first rule. That is, I will resume it to this. So in this case, we can see that it's similar to our equation. So if we see the x is the factor of b0 and b1. So in this case, it's the same as this one. So the first axioms is not failed. So we go on to the next. That is the same axiom as well, but with a different kind of rule, but I will skip that to make this video shorter. But the axiom 2 is also accepted. So we go to the third one, and this says if a10 plus a1, we say that a1 plus a0. So we can say that this is the same as this. So in this case, it's the same. We go to axiom 4. We let 0 plus 0 times x. So in this case, it will multiply by 0x, it will be 0 as well. So this is accepted. So we go to the fifth axiom. So it says that if we put a minus, our equation will be minus. So in this case, it's true. We go to axiom 6, and it says that k times a plus bx equal ka plus kbx. So in this case we multiply as well as this. So in this case we can say that a1x plus a1bx. So we have it here, a1x and b1x. So this is accepted as well. We have axiom 7, that is the same as this one, but with the case, like a plus b, okay, equals k b plus a. So in this case, it's accepted. We got to axiom 8, and it's the same as 6, but the difference is with that we have two multiplications, so it just multiply as a normal equation. So this is also accepted. We go to the 9, and it's the same as this one, but we add m k a plus bx a. So in this case, it's accepted as well. We go to the 10th, the last one, and it says if we multiply this by 1, it has to be the same. So in this case, it's the same. So this equation is accepted in our axiom, so it's true. We go to the other problem, and there are find the coordinates vectors. Vector. So I will avoid that, but we have 4 vectors. B0, B1, B2, B3. So in this case we have to put B1, B2, B3, and B0 as a matrix. So in this case, the first matrix we will have, it will be 1, 0, 0, 2, 2, 0, 3, 3, 3, 2, minus 1, 3. So we can see that if we have our vector 1, we can say that is 1, 0, 0. And we just put it in this order like a row, a column. So we have to do our Gauss-Jordan method. So in this case, we just put it in a ref. So in this case will be coordinate 3, 1, coordinate 2, minus 2, and coordinate 1, 3. So we go on with our next matrix, that is 1, 2, 3, minus 4, 5, 6, 7, minus 8, 9, 5, minus 12, 2. So in this case we have to find our Gauss-Jordan method. So we have that C3 is equal to 1, C2 is equal to 0, and C1 is equal to minus 2. So this is pretty easy to resolve. So now our problem was that this vector we wanna graph in a 3D. So we have our graph. We can say that this is x, x, z, and y. So we say that we have our x3, that in our case is gonna be x. So we can say that we have 1, we have minus 2 in y, we go this way, and we have 3 in x. X is 3, sorry, 3, and we say that our c is 1. So we can say that we just draw this and we put it up. So in this case we have a vector that is going this way into this point. So we just have to graph x, y, and then c to get our vector. The other one is also the same. So we could say that we have 1 that is c, so we have c, and then we have 0 that is y, and we have minus 2 that is here. So we stay here, we just go this way, and then we go up until we get towards c, and we get our vector. So this is all for the video, and I hope you enjoyed it.